is just from the book. As I mentioned before, it's 2-9. It says it on the homework on handout as well. But for the next few days, you guys will be learning how to convert all this into a nice organized table in order to get an equation from it, and then that way able to solve the equation. If you know everything we've been doing for a few days, you'll have the answer to whatever the original question was above. So let's dissect this a little bit, and we're going to be working backwards. That's a good way of doing math and learning it, backwards. So we learned all this, or reviewed anyway, all this stuff. It's calculated when needed. So the question becomes, how do we get to this equation? Above that we have a table. So look on here and tell me, where does this equation come from? By looking at the box. Where does it come from? So where do you see 5.5 times 10, 4.75 W plus equals, and 4.95 times 10 plus W? Okay. So you see it all right here. Okay, so that makes sense. Once we fill everything out properly, we have our equation. So if we can get to this point, we just have to add these two boxes and have it equal here. The last one. That kind of makes sense if we look at the headings here. It's like we're mixing two things together, fruits and nuts. So we're adding them together, and it's going to equal a trail mix. Trail mix is just a combination of fruits and nuts. So it makes sense if we get this, all these boxes filled out properly, we will have an equation solved, and then we'll go and solve it. That's there already. Next question is, where do these, how do I fill out this box? Where do these values come from? You'll notice directly to the left. So there's 5.5, or $5.50, and here's 10. So really, this is just a combination or a product of these two boxes. So we're starting off with a big 4x4 blank box, but we really start looking at dissecting it. Well, one of the rows and one of the columns is really just heading. We only use this upper left-hand box. The last column is just the product of these two. So we really just need to focus in on this, filling this out. We can fill this out. We'll know how to multiply them to get this box, multiply these with this box, do it 3 times with this box, and then we'll know this box plus this box equals this box, and it will give us an equation to solve sugar property and everything else that we might need to do. So it's really about today looking at this box. A few things to note. Look at this column only. 10 plus W, 10 plus W. Now these add up. Just like here, these add up. Do these add up? No. So some things add up, some things don't. It's like one of these do not add up, and we'll talk about why that is as well. Okay, so we can, the idea is to understand the structure and how things work, what the relationships are. So if we go ahead and change numbers, change the problem slightly, it won't mean anything different. We won't say, well, now how do you do it? It'll still be the same rules of what adds up, what equals what, and what does not add up. Okay. So let's talk a little bit about these mixture problems we're going to be doing. You guys will be doing mostly problems actually like this. Where we have these solutions. 30% of this, 25% of this, how many milliliters to make a 60% solution, and questions of like this and variations of this. And we're going to give you a nice method that works very well for all types of problems, not just this, but it'll be very similar. But in order to understand this, we got to talk about a few things first. All right. Number one. All right. If you have, watch up here. If you have two cylinders, cylinders. We have two cylinders, and this one is filled with 100% orange juice. And this one is filled with water. And since we're talking about percentage of juice, okay, we're going to say that this is 0% because it has no orange juice. You can't say, well, this is 100% water, this is 100% orange juice. But this is 100% juice, this is 0% juice. It has no juice in it, it's pure water. And we add these together. What is the concentration going to be? How much orange juice, how much water will be in the final mixture? Half. 50-50. Now, here's one thing. Do we know how much of each we're pouring in? No. So, if I did 1 liter of each, this is 1 liter and this is 1 liter. Okay, so this would be, first of all, how much would this be? 2 liters, right? So if I 1 liter and 1 liter makes 2 liters, this is why this box adds up. And we're adding them up. And 1 liter plus 2 liters, 1 liter plus 1 liter equals 2 liters, and so on. And we'll have how much of it will be juice, how much of it will be water. So yeah, here's a few things. All the concentrations have to add up to 100% total. We can't have more than 100%. That's the maximum possible, right? So if I have a liter of it is 100%, and the other liter is 0%, what's the concentration for the whole thing? You might say 50%, because half of it is orange juice, half of it is water. So this is what we're going to be looking at, is when we add different concentrations together, what's the mixture at the end? Or if we know we want to have 60% at the end, how much of each do we need to add together? What does the concentration have to do together? Another similar example, and this is for understanding purposes. What if I have 2 that are, let's say 50% each. Let's say these are all filled with only 50% concentration. So that means they're half orange juice, half water. Each 50%. 20%. Now, what is the concentration of the final mixture? Don't go by numbers. Don't go by, well, I see 2 numbers, and let me just add them together or divide them or something. But what would make more logical sense? This is half juice, half water. This is half juice, half water. What happens when we mix them together? What do you get? Yeah. Some people are saying 100%. People are saying 50%. Which one? Okay. So it should be 50%. Yeah. That makes sense. This is very, very important. That if you have half juice, half water, and you add to it half juice, half water, you still have half juice, half water. The concentration levels have not changed. You don't have more juice or more water now. It's stayed exactly the same. Okay? So make sure you keep that in mind. And this is why over here, here's the problem. This is why over here, these do not add up. This is why these do not add up. And they will never add up. And they should not, because logically, it does not make sense. Okay? So if you have half juice, half water, and then you have another thing of half juice, half water, if you add them together, you have 100% juice and no water anymore? No, it does not make sense. So this is very important. This is kind of background knowledge. If you were not good at these problems the last time through, it's little things like this that do make a difference. Understanding the problem, not just, well, I see a 50, a plus sign, and a 50, so 50 plus 50 is 100, and I don't know what that means, but I'm the numbers only. So understanding the question is very important here. Furthermore, a few other things that you might want to consider. What is another name for pure? I mean, another name for 100%. Say 100% something, we also would call it whole, or like I said as well, pure. So another thing I mentioned earlier about the hard thing about these types of problems is really the English language. So that when you're reading a problem, you come across something that says, oh, this is pure juice. You know that means 100%. Or it's pure water. Well, that's 0% juice or 0% something else. So you want to keep that in mind, that the word pure. And there's other similar words. Like there's other problems I've seen that talk about different types of milk. You have whole milk, you have 2%, you have 1%, you have non-fat. And somebody wants to ask me, well, it says non-fat. What's the percent? What's the percent of fat in non-fat milk?
0.
0. Someone actually asked me this. Now, here's what the thing is. Some of you are going to want to read this, but not really read it. You're going to do this. Anything that has a letter in it, you're going to want to ignore, and you're going to want to look just at this. And then you're going to find out that if you do look at only these numbers and try to just put these in the right place, you get completely lost. So this whole skimming, I'm just going to look only at the numbers, and all these other words are just a waste of time. They don't really help you with anything. That will make all of this very confusing. So if in the past your plan was to skip around, not really read the whole thing, and then later on you found out I really don't get this, they're related. Okay, so we're really going to read this and make sure we understand the questions, not just look for the numbers and see where they go, and not without interpreting what the sentence actually means. Because it could be a little confusing to do it that way. All right. So let's begin filling in this out. So using this as the model, okay, but I'm going to this one as the model. But I'm going to change things around a little bit. I'm always going to put the price or the percentage right here and the amount right here, just so that when we do the last column, it'll be a little bit neater. As far as the content, that will not change. So I recommend this. Once again, you're not going to use this box. This one, we're going to have either the percent or the price, okay, or cost. However you want to look at it, dollar sign. You can write this in. Always in this column we'll have that information. Okay. In this column we're always going to have the amount. And as we saw before, over here is really just the percent or price times amount. So the goal is really focusing on just filling in these 6 boxes. This is where what you fill in from the word problem. And once I have these 6 boxes, I just multiply here, and these 2 boxes will add up to equal the bottom. I know that the amounts will always add up, okay? But the percentages will not. Okay? 50% mixed with 50% equals 50%. You haven't changed any of the concentration levels, so your final, your total will not be different. There's different ways of looking at the headings here. We can think of this as the starting. And I'll usually denote it just as mixture A or something like that, and then what's being added to it. We call mixture B. And then the last one we'll say is the total. What's the total cost? What's the total amount? Or the final, what is the final mixture? So big idea, this is all the information that will not change. So for basically every problem, you'll be sketching one of these, filling all the headers in, right? Knowing that the amounts will add up and equal the bottom, and the percent times the amounts will add up and equal the bottom. And once again, this right here is where the equation comes from that you guys were practicing the past few days. So about getting to this point and then rewriting it horizontally and then just solving whatever that equation is. Now, don't want to, state too many things that are obvious. However, I hope it's clear that if you don't put the right information in these boxes, this will be wrong and the equation will be wrong. No matter how good you did the past 2 days of solving equations, you'll have the wrong answer. So it's really crucial to have these 6 boxes correct. So that's what we're really focusing on. And we're not going to worry about solving anything until end of Thursday and Friday. We're really just going to focus on, let's get the question down first, make sure we understand the question. So let's go through it and see what we know. So a health food store sells seasoning and blends. You've seen this only at a health food store, but like, what is it, like Sprouts or Whole Foods and those kinds, they have those where you just go and scoop as many of or whatever kind you want and one bag and make your own blend. Okay. It says one blend contains 20% basil. She either wants to add pure basil to some of the 20% blend to make 16 ounces of her own 30% blend. So let's figure out this information. What are we starting with? Starting with 20%. So we have 20%. Okay. What are we adding to it? What are we adding to? What's the percentage we're adding to?
20.
20?
Yeah.
Because it says 20 right here?
No, to the active basil.
What's that?
To add.
It's adding 100. So here's what I was talking about earlier, which warned you about. Some of you didn't take my advice yet. So now it's a direct consequence, as you can see. If you just look at, okay, the first number is 20, so that's 20. Hey, the second number I see without looking at any words is 20, so that means this is 20. And you start doing that without reading and understanding what the question is, this will happen to you every time. And you'll say, math is hard, these problems are hard, when it really has to do with you reading English properly. That's the hardest thing about this, is that you have to read English properly. It says, Sheila wants to add pure basil to some of the 20% blend. So this 20% is just talking about this, saying to your first starting point, it wants to add the 100%. So you have to read these properly in order to get them. Okay. To make a blend of 16 ounces, okay, of her own 30%. Okay, so what do we know? We're trying to end up with what?
30%.
30% is our final. That's the final mixture. And how much of this do we want? 16 ounces. The amount we're trying to look for is 16 ounces. And we can only get this information by reading this carefully and properly. So hopefully that's an eye-opening moment about just reading the question. So what else do we got? So the next, it says, let B represent the amount of basil she would add to the 20%. So should I put the B here or the B here? Top or bottom? Yeah.
Bottom.
Bottom. Alright. So one more time. B represents the amount of basil she should add to the 20% blend. So what percent are we adding to the 20% blend? 100%. That's what we're adding to 20%. So the amount we're looking for is right there. So again, we can't just say, well, it says let B be the variable, and then in the same sentence I see 20, so therefore B is next to 20. We have to read it and understand what the English actually says. Because B represents the basil we should add to the 20. So here's the 20, and we're adding B to it. Reading comprehension. Got it. All right, so last thing we need to consider is, well, what is this last amount? What is this last amount? So let's say, here's what we know. We have A, right? We have B, and these add up to equal 16, right? So, for example, what if this was 4? Let's just say B is 4. What would A end up being? 12. And how would you get that? Well, if you didn't know the answer was 12, how would you get it? 16 minus 4. All right. What if B was 6? What would A equal? 10. Once again, because 16 minus 6 is 10. So the way to figure out what amount of A we have is really just to do our final minus whatever B ends up being. B is 4, and we know we have 12. If B ends up being 6, we know this amount's going to be 10. We don't know. That's the problem. We can't really say, well, A is going to be 12 or something, or 5, because we don't know what this value is. Okay? And once again, is this true? Does this plus this equal this? This cell plus this cell equals this cell.
Yeah.
Yeah. 16 minus B plus B equals 16. Yeah, that's true. So it does work. So these columns do add up. A little bit of thinking here, right? A little bit of thinking English, a little bit about thinking logic. It's always helpful to start with numbers. If this right here was really difficult, start off with a number. Saying, well, I don't know what it is, but what if this B was a 7? Okay, this would have to be 9, because 9 plus 7 is 16. How did I get 9? Okay, 16 minus 7, so it's 16 minus, and you can go through that logic a few times, so it makes sense. Good, and then that's the hard part. We're done. That's the hardest part of the whole problem, is reading the English. Reading the English, making sure we understand what's being said. I can guarantee if your plan is to, once again, you see this whole word problem, you say, this is going to take me 20 seconds to read. And you say, I got a better idea. I'm going to just do this. I'm going to look at numbers only. And I'm going to ignore all these words because they don't really mean anything anyway. It's just a show. And you're just going to look only here and try to fill this out. It's not going to work. I guarantee you 100% of the time. So if that was your first instinct this time, try to avoid that. All right, let's just fill out the rest, though. Again, from here, it's not too bad. The only thing I'm going to do here is I'm going to convert the percent to a decimal because I don't want to work with equations that have the percent sign in them. So we convert it to a decimal. So what is 20% as a decimal? So move that decimal point. So this is 0.20 and the amount in parentheses. And it's just these two to the left of it, combined by multiplication, I use parentheses. 100%, what's 100% at the decimal? 1.0. And the amount of P on this one? And then lastly, we have
0.30.
0.30. And we have. So go ahead and write the full equation, but to the horizontal. So write this horizontally. We have 0, 16 minus b in parentheses, plus 1.0 b equals 3 times 16. And then that's what we're going to say. And again, my hope was by doing the Monday, Tuesday review on the equations that I show you this right now, you're like, okay, I know how to do that. You're not going to ask, okay, what do I do, or how do I do that, or do I do this next? Okay, that's my hope. But if not, here's more practice for you. So go ahead and solve this right now and see what you get. Okay. Solve, see what you get. No calculator should be needed. Here's what I mean. You might not, on the top of your mind, be able to do what a calculator does, like in your head, like do 0.2 times 16. I urge you to think about, well, what's 2 times 16? What's 2 times 16? 32. 32. So what's 0.2 times 16? Okay, 3.2, right? So calculator not really needed. Same thing with division. We can use 0.2b. I'll put 0.20. But be thinking about this idea is that if you don't know what 0.3 times 16 is, we'll just do 3 times 16 and move the decimal one time. And then you'll have it. Right, so go ahead and solve that, see what you get. You should probably have an answer of 2. Check my work. Answer of 2. Note the use of decimals. Just take out the decimals, then move the decimals back in. Sometimes helps. So maybe 1.6 divided by 0.8 doesn't really, click with you. But think of it as 16 divided by 8. 16 divided by 8 is 2. Or 0.8 times 2 is 1.6.
How do you get
2 negative 0.2b plus 1.0 and 1b equals a positive 8.8b.
How?
There's a 1.
It's arithmetic.
Minus
1 minus 0.2 is 0.8. Okay. So combining all the variables, you see.
There's a 1. Okay.
I know.
You minus that by the 0.8. There's a 1b and a 0.8b.
1 minus 0.2.
0.2, yeah.
It's
And you
0.8.
get 0.8.
Okay.
And minus.
Okay, so let's talk about what does this mean, though. Very important. Very important. What does this mean? What is 2? 2 what? All right, 2 ounces of what? Now, we just found out what B equals. What is B in our chart? Right here. So it's 2 ounces of the pure mix. 2 ounces of the 100% mix. And I have a sentence frame down here on the bottom. We should mix 2 ounces of the pure basil, that's 100%, right? With how many ounces of the 20%? Okay. We know it adds up to 16, right? And now we know this is 2. So how much of the 20% do we need? 14. Yeah. 14, 16 minus p. 14, 14 plus 2 is 16. So this is one full problem from beginning to end with all explanations involved. Okay. Okay. Now, hold on. Hold still. Hold still. Hold still. Put the backpack down. Put it down. Put it down. Hold still. Hold still. Come on. Hold still. Don't move around. Don't do anything. Come on, kids. Hold still. There we go. Okay. So, this is what you're going to be doing. Begin to end, and we took a whole period to do it. You guys want to get it down to about 5 minutes or less, for sure. Okay, so tomorrow in class, you're going to be given this right here. It's going to have 8 problems, and the goal is really just to have the table completed for all 8 problems. And I've stuck, and there's a lot of different problems, but I stuck mostly with the chemistry questions, just because really when you guys, if you guys take chemistry, it's the thing that can most directly affect you soonest. Chances are you're not going to go to the grocery store and start making trail mix anytime soon. But you might take chemistry, and this is useful so you don't blow up the building. Okay? And might also throw out that with chemistry, 0.1 grams of something is very different from 10 grams of something. You might say that, well, it's kind of close, it's just I miss a decimal point, and realize on chemistry that's the difference between something good and something really bad, or it's nothing at all. So don't throw like the decimal points and say, they don't really matter. It actually does matter quite a bit. Okay, so let's end with that.